Hi, everybody. I'm going to try to do a really quick tutorial on how to solve Hardy-Weinberg problems. What we're going to try to particularly figure out is what percent of a population are homozygous dominant and what percent of the population are heterozygous. We can see the population that is homozygous recessive. What we can't tell is the organisms that look dominant. What's the difference between the heterozygotes and the homozygous dominant? And that's what we're going to calculate here. So I've written a story problem up on the board, and I'm just going to solve it with you quickly. Imagine that you have a population of 2,500 individuals. The dominant trait, 2,000 of them have the dominant trait. And the question that we're going to try to solve today is what percent of that population are the heterozygotes? Now, up on the board, I also have the Hardy-Weinberg equation. For my test, you are absolutely going to need to have this equation memorized. We've done it over and over and over again. It's the same. It is so repetitive. No reason not to have this memorized. So just to remind you, the equation is p squared plus 2pq plus q squared equals 1, basically. And you need to remember that p plus q equals 1. P refers to the dominant trait and q refers to the recessive trait. In the equation, p squareds are the homozygous dominant, and that's why I put 2 capital E's, is just to remind you, homozygous dominant. 2pq are the heterozygotes, and I wrote big E, little e to remind you that that's a capital and a lowercase. They are also called carriers, and if you're heterozygous, you are a carrier. And then the q squared are the homozygous recessives. Now, with the Hardy-Weinberg problem, every single time you do this problem, you will always start with the homozygous recessives. Those are the ones that you can see. You can't tell the difference between heterozygotes and homozygous dominant. So in our story problem, I gave you the dominants. You need to start with the recessives. So the very first thing you're going to do is tell me, hey, KJ, I'm not interested in the 2,000. I'm interested in the 500 that must be recessive. Process of elimination, you must be able to figure out the 2,500 population. If 2,000 are dominant, 500 must be recessive. So that's how we're going to start. So you start with 500 out of the whole population of 2,500. Those are your homozygous recessives. Those are your q squared. Don't skip steps. Write everything. So we're going to do the math. 500 divided by 2,500 is 0.2. Somebody solved this with me a few minutes ago, so I actually have it. I'll grab my calculator just in case I forget. To help people who are struggling on this, I always emphasize the squared part. So q squared equals 0.2. We need p and q by itself. So we remember that p plus q equals 1. Keep that in the back of your mind, okay? So if q squared is 0.2, what's q? Well, you take the square root of both sides of the equation. So if you take the square root of a square, you end up with just q all by itself. And then you take the square root of 0.2, and I got to turn my calculator on, 0.2 square root 0.45. Q is 0.45. Now remember this equation over here, if you put p and q together, it will equal 1. So if I rearrange that equation, I can say 1 minus 0.45 gives us 0.55, and that must be p. If you're not convinced, 0.55 plus 0.45 equal 1. So we've got our p and q. Now all it asked for was the percent of heterozygotes. So now we have all of our variables. We've got p and q. We just plug them into that part of the equation. In this case, we plug it into 2pq. So 2pq, those are the heterozygotes or the carriers. So it's 2 times p, we said was 0.55, times q, we said was 0.45, and it comes out to be, I don't remember off the top of my head, so I'm going to do 0.45 times 0.55 times 2 equals, and the answer is 0.495. This is the frequency. When it's left as a decimal, that's the frequency. You move it over by 2 decimals to get 49.5%, and that is the answer. We just answered that problem. I would like to do another really quick one with you. I don't know if the camera will cut off. I only get 10 minutes on this, but I'll try another one that's a little bit harder and is worth extra credit on my test. Let's imagine for a second that you have a genetic disorder. We're talking about a genetic disorder that is 1 in a million. What makes this problem difficult is that it has tiny numbers in it. So these are the recessives. 1 in a million are the recessives. And the question is, what percent of people are going to be carriers? And remember that carriers are the heterozygotes. So that's what we're going to try to solve. Those are the heterozygotes. And then to get extra credit on my test, if you have a town of 10,000, how many will be carriers? So that's the extra step. So let's start with the beginning. 1 out of a million, that is the recessive. So we're starting out on the right foot already. We don't have to figure out the dominants, we just figure out the recessives. 1 out of a million is your q squared. I'm writing really fast because I think I'm going to run out of time. So that is the same as the decimal point 0, 0, 0. I can't remember how many zeros, so give me a second so that I do it right. 1 divided by 1, 0, 0, 0, 0, 0. I should have my glasses on when I do this. Equals, I need 1, 2, 3, 4 zeros. The math teachers are going to be disappointed in me, I'm sure. So that's q squared. Q squared. We're trying to figure out the heterozygotes, so we need q by itself and p. So we're going to take the square root of q squared, sorry. So I do 0.0001, and I take the square root of it, and that is a weird number, 003, we'll say 0032. I'm going to round it to 0.0032. That's q. To figure out p plus q equals 1. So all you do is 1 minus q. You haven't seen a number this small before, so this is a little difficult. 0032. So p is going to be a really big number. P is 0.99, we'll say 7. That's p. Now you just do 2pq again. 2 times p times q to figure out the percent or the frequency of heterozygotes. So 2 times p is this number right here, 0.997. Q is this tiny number up here, 0.0032. It's going to take me a moment to enter them into my calculator. So 2 times 0.997 times 0.0032 equals, and the answer is 0.0064. I'm rounding again. So that's the frequency. That's what we call the frequency. To get the percent, we scoot it over by 2 decimals. So the percent is 0.64% of the population are heterozygotes. And we've answered this question right here. 0.64% are the heterozygotes. Now to figure out how many that is in a population of 10,000, that's where we take this original number, the frequency, and multiply it by 10,000. And so I'll do that right here. So 0.0064 times the population of 10,000 gives us, so I'll do 0.0064 times 10,000 equals 64. You would have 64 individuals in a town of 10,000 that would be the heterozygotes, the carriers. I finished. Let me know if you have any questions.